Morning, we'll be starting up here in about another minute or so. And you may want to open up your chat pod and your Q&A pod. The chat pod will be where we send you messages, and the Q&A is where you can put in questions for Willy. Okay, we've got a few folks drifting in, but we're gonna go ahead and get started. Good morning, my name is David Orr. I'm the director here at the New York State LTAP, the Cornell Local Roads Program. I want to welcome you to one of our Tuesday webinars on foundational, why we're doing things kind of stuff. We'll be doing these for the middle of March and then switching to our in-person workshops after that. So our website, you can register for all of these events and hope that they're enjoyable and useful to you. Today we're going to be doing culverts, and our instructor today is Willy Grimke, who was with Washington County for over a decade. I will let him do a little bit more of his background for you. You do want to open up your chat pod. There are two things that will help you there. One of them is you'll get a link to the handout. There's a handout today which has some resources you may want to look at later on, and a list of all the webinars. And then also we're going to be using Poll Everywhere to get some feedback from you, and you can get the link on that and have to type it all in. It's easier that way. And then of course, open up your Q&A as well for sending us questions. Anything, we'll take care of it. If it's technical, it'll be Willy. If it's something in the background, Adam and Amanda, who are monitoring in the background, will take care of it. They're excellent at that. I want to thank them for all the work they do on that area. So with that, Willy, it's all yours. I'm going to go dark and go mute, and have a good day.
Great. Good morning, everyone. It's a lovely winter day in upstate New York, and we're going to talk a little bit about culverts this morning. I'm Willy Grimke. I work for Greenman Peterson, a consulting firm out of their Albany, New York office. And prior to that, I spent some 13 years as the superintendent of public works at Washington County, and then prior to that had some time in consulting and with the state of Connecticut. What we're going to talk about today is culverts and what kinds of deterioration we're likely to see, and preservation and repair techniques to keep them functioning. Okay. So as we move through this webinar, up on your screen for the Zoom session, you can chat, raise hand, ask questions, and we'll try and deal with those as we go through the seminar. If you have any things you're interested in or want to talk about or need more detail on or clarification. So we get PDHs for this, one in New York State, but it's only for the person registered for this course. And you'll get a certificate of attendance sent. Not sure about other states. I'll let the folks at Cornell Local Roads weigh in on that if they later in the presentation. Okay, so our learning outcomes today. What we're going to do is talk about common deficiencies that are identified in culverts, describe preventative maintenance techniques, and review some repair techniques. So you should be able to discuss and understand these items by the end of the webinar today. So right now, we've got the survey up. What's your primary job function? Who are highway maintenance workers, supervisors, engineers, or other? And it's looking like we have mostly engineers. And then we have some heavily, super majority of engineers. All right. I'm going to move on. Okay, next question is, who do you work for? Town government, county, city, state, private sector, tribal government? Okay.
And really, just so you know, we got a couple of folks who didn't access Pole EV. They put in town and city. So we got one more town and one more city.
Okay. So it's looking like it's roughly a third state and a little over a quarter county, a little under a quarter. Oh, more town folks. Good. Okay, so we get an idea of who's here and what their background is, and some city folks. All right. Okay. How long have you done this kind of work? Highways, highways and drainage. So it looks like we've got some new people. We've got some folks that probably can give me some instruction. And folks in between. Okay. Now, if you're responsible for culverts in your inventory, how many do you have? And it looks like a plurality at this point has over 100. And that was my experience when I was in county government. We had some 100+ bridges, and we had well over 200 culverts in the 5 to 20 foot range. Okay. So before I go into the terminology and nomenclature, I'll deal a little bit with why are we here and even having this discussion. Well, you'll see from some of the photos of some of the failures that when a culvert doesn't take the water it needs to take, or it starts to fail, inherently it will cause the road around it to fail. And we're trying to keep our roads functional, those working, not overtopping, passing enough water so we don't get flooding issues, and not just washing out and having problems with our road that we're going to have to fix. So basic terminology: invert, It's the portion at the bottom of the culvert where the water will flow during low flow situations. The haunch is the area between the invert and the spring line underneath the culvert that it's supported, the earth area that's supporting the culvert. The crown is the top of the culvert, and the spring line is the widest point in the culvert. That is part way or midway up. Halfway up on a round culvert, it'll be at a different location at a pipe arch. Okay, and then this is a longitudinal cross section. Sometimes we'll have aprons at the inlet and outlet, which will help to minimize or prevent erosion. Sometimes there will be a toe or cutoff wall, either from the opening of the culvert or from the edge of the apron, which will reduce scour potential. There may be wing walls to retain the embankment that the culvert's buried in. We may have a head wall or parapet. Number of pipe type culverts will have joints, and the barrel of the culvert is the basically wall of the pipe. Culverts can come in a variety of shapes. They may be round. We may have square boxes. We may have bottomless boxes. We may also have arches, pipe arches, or bottomless corrugated arches. Materials. Concrete is one of the common materials. We had a number of concrete culverts in our county system that had been installed back in the 40s, 50s, 60s. Concrete is rigid. It needs to be adequately bedded when it's set. You have joints every 8 or so feet apart. Nice thing about concrete culverts is you have a smooth interior. Sometimes they can be skewed, but installation of concrete culverts is dependent on having them adequately bedded. And here are some photos of concrete culverts. We've got a pair of round pipes in the upper photo. You can have horizontal elliptical pipes, concrete arch pipes, and then in the lower photo, we've got a precast box culvert that is bottomless, sitting on a footing, but will have a natural stream bottom. Okay, we have a question. For an embedded culvert, do you seed the bottom with riprap at installation time, or just let this stream sediment transport fill it in? And I'm going to give you the definitive, it depends. In the photo we're showing here, there is riprap protecting the footing, but natural stream bottom down the middle. And that is a common situation with new bottomless culverts, where there will be some sort of armoring along the face of the footing, and then natural stream bottom in the invert area. Okay, another material, corrugated metal. It is flexible, but the corrugated metal is dependent on the interaction with the surrounding soil. To some degree, the corrugated metal pipe is a form, and the soil is basically doing the work of carrying the loads from above. Corrugated metal does have a rough flow surface, and the joints are going to be about 20 feet apart. Metal culverts, typically steel or aluminum. You can get the round ones up to 15 feet in diameter. Some plate pipe arches, you'll get up to 50 plus foot spans. And like I said, the material is somewhat flexible. So as the soil moves around it, you can get some deformations in your metal pipe. And in solid pieces, round pipe, the joints are typically 20 feet apart. However, with plate pipes or plate arches, it will be a series of plates with a more or less random spacing of joints based on the plate sizes. High density polyethylene seems to be what's being used for mostly smaller pipes, 5 feet and less. Those are flexible, much like the metal pipes. Smooth corrugated, smooth lined are available. Also corrugated interior are available. And these two, like the metal, are dependent on that soil interaction. Okay, embedded with round 6 feet or Tim Clark for smaller pipes. Typically, we embed the pipe and let natural course of stream migration carry the soil into the pipe, and let that happen naturally if we want an embedded pipe. Okay. This is one of the keys to the whole discussion today. If we properly install our culverts, it will help reduce the maintenance problems we have over time. If you don't install it correctly, you will probably be fighting with maintenance issues over time. We had one culvert, it was actually a pair of them, and one of the two twins was not installed correctly, and there was a big dent in it. It was a bridge, and it was regularly being identified as a red flag because apparently when it was being backfilled, they backed over it with an excavator. But joints will leak if it's not installed correctly. It can deform, displace, and you'll have ongoing problems. And then secondarily, if you properly maintain your culverts, you can postpone or delay having to dig it up and replace it. So common things we encounter are defects or problems we have to deal with our culverts from a maintenance situation. Siltation and debris, leaking joints, settlement, scour. The coatings can be damaged on metal pipes, which will start to accelerate corrosion. We can have issues with our invert deteriorating from either scour or abrasion, or from corrosion. We can get localized damage, cracks and spalls, so a variety of things can go wrong. So we'll start out with debris and siltation. This is one of those favorite twin tubes, and when you have twins, routinely what will happen is the stream will tend to migrate primarily to one, and we may end up with silt deposition and vegetation growing on that deposited silt, reducing the waterway opening and capacity. of the assembly. You know, we get a big rain event and the culvert over on the right is not going to take the flow that we need it to take. The other thing that routinely happens in this type of application is that little area between the two pipes, even if they are open and flowing, will routinely catch debris, and we have to get rid of those, get rid of that debris, because debris accumulated there can both impair waterway opening or cause turbulent flow in and around the inlet of the pipe and create a scour hole at that inlet. And if we have a problem with impaired waterway opening in a big event, it could potentially cause the road to overtop. This is a general, it depends discussion. Sometimes we want some soil in the bottom of our culvert because it's a embedded culvert and we want to have a correct wildlife habitat. However, we're talking about soil that we're not planning to have in the culvert here. It may be an indication of failed joints. It may be an indication of your stream situation is changing and you're starting to get aggradation. But it can, if you have a disproportionate amount of soil in your culvert, it can impair your waterway opening and your capacity. It also may be an indication that you've got joints failing or some other kind of failure that's letting your embankment fill up your culvert. Okay, debris in culvert. So this was a fairly significant water flow event, and it discharged, washed a lot of debris downstream, and it got into this twin box culvert and impaired the waterway opening and actually caused overtop or exacerbated the overtopping. So the road overtopped, and as you can see, not only did the road overtop because the culvert couldn't pass the water, but the embankment washed away. So the road had to be reconstructed. So this is a stark reasoning why you want to keep an eye on debris in your culverts and keep them cleaned out. Okay. So another issue we can encounter are leaking joints. So they may be have separated or misaligned due to settlement. They could be damaged during installation. We could have poor bedding and subgrade. One of the cases I observed recently is a lengthy concrete box culvert was installed under what was to become a 40-foot high fill, and it was installed on clay soils. And a year later, when that was being inspected, we observed joints opening up between each box, particularly in the middle of the length of culvert, because that's where the highest fill was, and that's where we had the most settlement in the clay. So those joints all had to be sealed up to prevent the embankment material from migrating into the culvert. things that can happen with joint defects or open joints. In the photo you see, you've got water infiltration, and this is during the winter time. So we're going to end up, we've got the ice forming. You can get soil infiltration. And when that happens over time, that soil infiltration can lead to sinkholes or voids in your embankment and under your road. And that infiltration of soil and water can destabilize your pipe bedding over time also. So here's a joint failure with loss of soil as well as a failing invert. And this is a case where things on the surface don't really appear so bad. It's a small hole, but what was underneath that hole was a 4-foot diameter by 4-foot deep void where material had infiltrated into the culvert under the road. Sometimes we can get scour or undermining. This was a twin boxes downstream from the ones we saw earlier. And well, at this location, the embankment was high enough that it didn't overtop. The water coming out of that culvert basically scoured out that hillside next to it. We may also get localized dents and damage, and may be an indication of poor construction practice. But in this photo, with that big dent in the pipe, it's not gonna, this pipe is not gonna have the capacity that was originally designed for. It can also make joint failures worse or more severe. And then from a repair standpoint, you may not be able to reline it because slip lining is probably not going to be an option unless you're taking a huge waterway area penalty. Here's another one that was deformed, and it's got kind of a bow in the top. We can get cracks and spalls in concrete pipe, like we often get in all concrete. How the pipe is cracking may indicate what the failure mechanism is and what happened during installation. If you have longitudinal cracks at 12, 3, 6, and 9 o'clock positions, it's often due to poor side support. You don't have adequate compaction at the sides of the pipe. And if it's at like 5 and 7 o'clock longitudinally, it may be due to poor haunch support while the pipe was installed. Yeah, if you have transverse or radial cracking, it can indicate how the pipe was installed or bedded. If it's at the invert, it'll be due to inadequate support in the middle of the pipe section. And if those cracks are primarily at the crown or widest at the crown, it's due to inadequate support at the ends of the pipe. This next diagram kind of illustrates that. If you're properly bedded, your concrete pipe should be fully supported and sit nicely. If it's supported at the bells but not in the middle, you'll get the broken belly kind of cracking. And if the bells are inadequately supported but the middle part of each pipe is supported, you'll get the broken back type cracking. We can over time have damaged coatings. This is a case where we've got a galvanized corrugated metal pipe, and I bet you can all guess where the normal high water mark is for this pipe. And the galvanization is deteriorating over time. Now, this in and of itself isn't a huge problem, but what it means is that galvanization is no longer protecting the metal pipe, and the corrosion will accelerate over time. And how that corrosion appears, it will often start down in the invert, and it'll start to be pitting, and then you'll get some flaking and rusting, and the steel will start to go away. And not all soils will support metal pipes. If you have acidic or saline water or soils with low electrical resistivity, you will get accelerated corrosion. I was in Wisconsin last week, and the folks at the DOT there do not use metal pipes because of their soils, and they have accelerated corrosion when they do. Invert deterioration. This can happen in both concrete and metal pipes. You may have abrasive bed load, basically carrying rocks and sand that just scour it out, or you may have like high sulfates in the water, which will deteriorate your inverts on concrete pipe. And if the invert deteriorates over time, it will weaken and destabilize the pipe as a whole. Here's some metal pipes where the inverts are shot. Again, water or soil chemistry and abrasion in metal pipes. What happens is the abrasive bed load in the creek will scour off the zinc in the galvanized coating, and then the corrosion starts to work. And as you can see with these, over time, with no invert, the pipe is likely to start deforming and collapsing. Now, here in the photos, we have sediment and sinkholes, and basically water is carrying soils into the culvert and away. So you've either got a invert problem or a joint problem or some other issue where the settlement or the sinkhole, though it's a problem in and of itself, it's actually the symptom of another problem, which is some sort of lack of integrity of your culvert. And here's a failed invert, and then we're just getting scour and the culvert's undermined. We can also get collapse, where the culvert will just would be overloaded, or it looks like in this photo there's some kind of boulder or something that's punching the crown down, collapsing it. So we've talked about all these things that can go wrong. What are some PM steps we can take to help make our culverts last longer? And we'll start out with debris removal. You know, PM, we get rid of debris, sediment, vegetation, so our culverts function like they're supposed to, and then we can talk about armoring for scour protection also. So how we remove debris or silt is highly dependent on the types of debris we have and what we're trying to get out of here. In this particular photo, we've got a stock fence with, you know, sticks and root ball hung up on it. And that's the type of thing you can probably send somebody in to retrieve it or pull it out with a cable, something of that nature. If you've got silt, like we have in the bottom of the culvert, we are going to want to look at a different measure, maybe digging it out. And again, this is a function of what our size of the culvert and environmental restrictions. So things we need to think about: cleaning it out. How are we going to contain the silt and debris? Because we're going to be beyond whatever nationwide permit or DEC MOUs we have, just letting it all wash downstream. And then if we're putting somebody in there, we think we need to be concerned about confined space and also any potential contaminants, issues with the water, and careful how we do things because we don't want to wash one of our employees downstream. Okay, large debris. Variety of strategies for getting woody debris, beaver dams, that kind of thing cleaned up, particularly if it's the inlet and outlet. Excavators or large equipment. Excavator with a thumb works pretty well. Hooking onto it with a cable, putting somebody in there. Probably don't want to be dismantling too many things from the downstream side. And then I've also seen excavator with a thumb taking a log or telephone pole or something like that and pushing the clog or debris away and getting it out, and that would be a mandrel. Okay. For silt removal methods, you can, if you have access to them, vacuum truck, water jet or sewer jet, fire hose, bucket line, and if it's big enough, small skid steer. All of these require some ability to capture and retain silt so you're not impairing the waters. I'm going to back up with water sewer jet. When I was in county government, we had an old one that the sewer district had retired, and for relatively small diameter culverts, they worked pretty well. However, you have to be careful that you don't want to run a sewer jet through a culvert that either has open joints or perforations in the invert. You can cause yourselves quite a bit of problem doing that. Okay, scour repair. If you have scour issues, you can look at repairing them, but you're going to want to talk to your hydraulics engineer or get a hydraulics engineer involved so you're using the appropriate materials. In addition to stone, you may want to grout things in place. You may want to look at geotextile, cut-off walls, etc. And you want to know how deep your maximum probable scour depth is going to be, and also what size stone you need to be using, because if you use, let's say, fine stone fill or number 3 stone or something, and you've got a fast moving stream, all that's essentially going to do is wash downstream in the next big event. And also with any stream work, you need to make sure you have the required environmental permits. Okay, in Michigan, they have some bottomless culverts, and they do some scour repair along the footings of bottomless culverts, but one of the challenges is getting the riprap in there. So they built this pretty cool contraption to help themselves get the riprap in there. So they've got this essentially floating box that's got riprap in that hopper in the middle. And it's got you can kind of see at the bottom under the hopper, it's open. So they float the box into place to get the riprap where they want it. And drop it in. Other thing you can do is riprap create a riprap apron at the inlet or outlet if you're having erosion or scour at the inlet or outlet. You should also look at a concrete apron. Basically to in that area where the velocity is increasing as the water is going in your culvert. If you have potential undermining, you can look at installation of toe walls. We can also do invert repairs as the invert is being distressed or failing, and joint repairs. So toe wall or cutoff wall may prevent undermining. It's not going to prevent the scour hole. You may still get a scour hole developing in front of it, but you want to make sure that that cutoff wall is below the elevation of the maximum scour depth, so it won't undermine the pipe. And here's a detail from Georgia DOT. Basically, how you do that, you divert the stream, you form your toe wall. If it's a concrete culvert, you'll anchor the wall to the culvert, place and cure, and then get your stream back in place and backfill the area you excavated before you divert the stream. Invert repairs. If your invert is failing, you can do a concrete paved invert. This is a pipe under New York State Route 29 here in Greenwich that New York State DOT put in a concrete invert. You can also use armor plates or a geosynthetic cementitious composite mat, and we'll talk about that in a minute. So concrete paved invert, you have to divert the stream, clean the area, form in place concrete, let it cure and restore the stream flow. In this detail, the concrete is reinforced and anchored to the bottom of the culvert, and there is some minor reduction in waterway area. However, you get a smooth invert, and it does restore the structural integrity of your culvert. So it can buy you time before you have to replace it. Another invert repair technique is armor plates. Caltrans uses these, and I've got a photo of Caltrans installation. If you have severe abrasion problems, you put a steel plate in that's going to resist abrasion and basically weld it down. Now, DEC may not be happy with this from a aquatic habitat standpoint, because as you can see from the photo on the left, you don't have a concentrated flow in the invert anymore, it's spread out. And over on the right is the installation proceeding. They're welding the plates down. Yeah, but And then the area underneath is concreted in. Another invert repair technique is a geosynthetic cementitious composite mat. Essentially what this is, it's a sandwich of non-woven geotextile with a mortar mix in between. And the pieces are laid down shingle style, attached to the bottom of the culvert. This is done after the stream's diverted and it's cleaned and any holes are repaired. And then water sprayed on it, having it allowed to cure. And then you have a new, basically concrete shell type of invert. Now, when we get to joints, depending on your material and depending on the situation, you've got some steps you can take to repair your joints so they don't leak and put soils in to the ground or into your culvert, hence causing voids and sinkholes. So you can use internal bands, internal joint seals, flexible chemical grout, or concrete collars. Internal bands, they are generally soil tight. They're not necessarily watertight, and the band is placed over the joint inside and tightened into place. You can see the bolts in the photo at about 4 o'clock and 8 o'clock, and those are tightened into place, and it forms a seal and keeps the joints from leaking. This can be used if they're separated but in reasonably good alignment, and you want to be careful with this type of installation that you get the bolts up out of the flow as much as possible so you're not catching debris. Flexible chemical grout injection, it can be either injected into the joints from inside the culvert, or it can be drilled in through the embankment and injected into the joint area. That's what we did on that box culvert that settled. It went in from below and filled the joints. It was like expanding foam insulation, like the great stuff you would use around your house. And it seems to be doing a good job sealing those open joints off. And in more extreme cases, you can pour a concrete collar around your open joint, but you have to excavate to get down to it to pour the concrete collar. And the other thing you need to be very careful while you're doing this is make sure you form up adequately around the open joint, so when you're placing the concrete collar, you're not filling your culvert with concrete. Okay, relining. We'll talk about some of the relining options here. We can slip line with a variety of materials. We can do shotcrete or spin cast concrete liner or cured in place pipe. And the photo you see here is a completed slip line corrugated metal pipe or corrugated metal arch. So materials that can be used for slip lining, you can use corrugated metal pipe or corrugated metal, both, plate pipe and plate arch, smooth interior metal pipe, which you see in the photo, or high density polyethylene. Depending on what you're looking for waterway opening, you can get the snap together polyethylene smooth line thick wall pipe, or if you can afford the reduction in waterway area, loss, you can use normal corrugated HDPE. Here's a series of slides of this was the Washington County crew installing that plate pipe arch or plate arch. And basically they cast new footings just inside the old footings and picks up to erect the pipe and erect the arch and then slide it in place. And this is once it was slid in place, and you can see the on the photo on the left, we have the annular space between the old and new arch. And then on the right, we have it formed up. This particular location, the original arch was built in the late 30s, and it had started to fail actually right or just above the footing because the water would routinely come up above the footing elevation and cause corrosion. But it lasted like 70 years. So this new installation should also last another 70. The forming on this particular installation was a little more challenging because of the skewed ends. The culvert was on a skew. So making sure that we didn't have concrete oozing out when we were filling that annular space was a problem, and that required a little more time forming that. And in this situation, we could close the road temporarily, and we filled that space from the top. So you can see in the upper left, excavated down from the crown, from the roadway to the crown of the old pipe, and then used a self-consolidating concrete to fill that in. For other applications, if you're using a smooth interior pipe and sliding it in place, as shown lower left, you would have grout ports in the pipe as seen in the lower right, and grout is injected into that annular space. So essentially we have a layer of steel, layer of concrete, layer of steel. So we have a sandwich pipe installation. And for a smaller type pipe, this is a smooth line thick wall HDPE. Tubes were placed in the annular space and grout was injected through these tubes. And each of these tubes is at a slightly different depth into the pipe, so it could be, the whole thing could be filled. Now we move on to shotcrete and spin cast concrete liner. Basically, this creates a new concrete interior for your pipe. It's pretty close to uniform thickness over the existing one. And unlike the slip lining options, which aren't real good with distortions, this essentially goes right over them. So the pipe needs to be cleaned and any voids grouted, particularly if you have issues with your invert. And what you see in this photo here is a spin casting operation. And essentially it's just a mobile spinning shotcrete machine, and it sprays concrete all around the interior perimeter of the pipe. For larger locations where somebody can get in there, shotcrete can be used. There was a federal aid project up in Essex County several years ago where on the road that's the approach to the IP plant, I believe it's Shore Airport Road, and shotcrete was installed up there. Okay, Joe wants to know, how can you guarantee that the grout fills the space totally between the new pipe and the existing pipe? Basically, in response to that, it's kind of an iterative process. Best practice is to start at the bottom and fill the bottom up and let that set, and then come and do more. But also, it will require some inspection. So once it's in place, inspection staff will go in and basically sound the metal pipe, and you can tell if there's a grout void or not. And then if there are any voids, that'll need a new grout port will need to be installed, and those void areas will need to be filled. Okay, relining culverts with cured in place pipe. What this is it's like a resin impregnated felt liner, and the resin, it smells just like the stuff you use to build fiberglass boats. Air pressure or water pressure is used to hold the liner against that host pipe, and then it's either cured with hot air, hot water, steam, because the resin is a thermosetting resin. It'll take the pipe out of service while you're doing it, but you, depending on the design, you can have a fairly thick, 3/4 inch new smooth line pipe. Now, the process for this is it's impregnated, and essentially it's inside out. And then the pipe is, the liner is fastened on a insertion assembly, and then it's filled with water, and the water will push it up against the existing pipe. And then once the whole pipe is in place, the water is heated to cure it. And once you get beyond the cure period, you have a new liner, and this is what the liner looks like when it's coming out the other side. You can see the felt, it's inside out. After this is complete, this will be cut away, or the water drained, it cut away, and then you'll have a brand new liner. Footing repair in bottomless culverts. We showed a little bit the PM Scour Repair with the Michigan DOT video, but with this, it's can be challenging because we're working in tight spaces. You got to do stream diversions, get to the extent of sound concrete, and you need to go down below water depth. In Washington County, our crews did a couple of these, and in this particular case, we needed to repair the footing and used a couple of HDPE pipes for stream diversion so we could work in the dry. Unfortunately, during the middle of the project, it was summertime and we had a cloud burst, and it overtopped our cofferdam and washed one of those sections of pipes downstream. But basic technique for that is remove the unsound concrete, get the sound concrete, repair any reinforcing, clean, form, place. And then if you use a bonding agent, do that. place your concrete and cure and reestablish your stream. Okay, so we've discussed common deficiencies. We've discussed some PM, and we've discussed some repair of culverts. So now we've got a few poll questions. So corrosion in metal pipes could lead to which of the following? Invert damage, deformation, undermining, or all of the above? Okay, so we're at 100%. So yeah, corrosion can lead to invert damage or deterioration of the inlet of the invert. If it could also lead to deformation as the pipe becomes structurally unstable. It can cause it to be undermined. So all of the above is correct. Okay. Next question, what would be a preventive maintenance method for prevention of scour? Placement of a riprap or concrete apron, installation of a toe cutoff wall, slip lining, geosynthetic armor plate, or A and B only? Okay. Got a question. No question. So what we're looking for is A and B only. The slip lining or cured in place pipe are probably not going to have an impact on scour. And in fact, depending on the material you used, if it does accelerate velocities, could potentially make scour worse. And the geosynthetic mat or armor plate likewise are not going to have a significant impact on scour, where the riprap or concrete apron or the toe or cutoff will both help make your minimize your scour issues. Okay, which is not a viable method for lining a culvert with significant deformations? Cured in place pipe, shotcrete or spin cast, slip lining, or none of the above? Okay, so this is one of those ones that's subject to some debate based on significant. Significant is, can you slide the liner through? If it's really, really significant and will impair your waterway opening, you don't want to do any of them. But if it's small enough, if the deformations are small enough that you can shotcrete, spin cast, or cured in place, you could do that. So that's an it depends category. I am going to, okay, and I have two questions. Do town and counties do hydraulic designs for every culvert, or only over a certain size? In our county, when we were replacing pipes, if we had we didn't have issues, we would just replace them in kind. However, if we had issues, we would, do hydraulics or hydrology design. do some hydrology and hydraulics design. And secondly, have you ever heard of a downstream landowner seeking damages after a washout on a public highway? Yes, absolutely. They will seek damages. They may not be able to recover them, but people will often seek damages when they feel as though they had their property damaged and it's not their fault. And if you'll have to talk to your attorney about how best to defend that type of thing and make sure you were doing the right thing in the first place. Okay, it's looks like it's no, it's 10:05, but I ran a little bit long, but if anybody has any questions, let me know. Enjoyable as always. And I believe that concludes our webinar for today.